Hello, my name's George Kenny and I'm a systems engineer for Veeam software. I'd like to talk to you today on the subject of protecting against modern ransomware with Veeam. Now the purpose of this particular session, very short and sweet, is to run a live ransomware attack on a isolated and controlled virtual machine in my own lab. Okay? And the purpose of that is I want to show you how after that particular incident we can recover instantly with Veeam software. Okay? Now, I'm not going to cover off any of the background of ransomware or the purpose of it, so on and so forth. We all have seen and heard on the news about what ransomware is. We're all very well educated on that piece. Okay, but I am going to show you some of the mechanics of it, what it does in the background, and that's very important to understand that this allows us to understand some of the things we should be doing in an environment and some of the things we should be trying to avoid to try to make sure we're protected. Okay. And equally so with the demonstration, some of our software allows us to spin up virtual machines from backups very quickly, almost within 2 minutes. So the purpose of this is to show you how that actually works so quickly after suffering a ransomware attack. And it really is applicable to something that isn't just in a lab environment. It could be a production workload with several terabytes or petabytes, dare I say, of data that have been corrupted, and you can spin that up in that same very small fraction of time. So let's dive straight in and have a look at what's going on. So here's my virtual machine. You can see here I have a number of files on the desktop. These maybe represent files that you have on your desktop, maybe on your workstation at home or at work. Standard Word documents. Let's just open them up and have a look. See, you've got some data in them with an image. Let's go and have a look at the Excel spreadsheets, just some standard spreadsheet data we've got in there. Let's close that off, and I've included an image that I've just downloaded from Google. It's a JPEG, but again that might be indicative of honeymoon photos, holiday photos, photos that live on a corporate network that are designed for some sort of surveying, so on and so forth. All the typical stuff you'd see on a typical computer or server in the modern day era. Okay. Now not only that, let's go and have a look a little bit further. On this machine we have a drive mapping, okay? So we have a share to another system, a direct and isolated connection to another system in my lab, mapped to the drive letter S. If we go into that, we can see there's more data, more Microsoft Office data, Word documents, Excel, so on and so forth. I've just copied and pasted the same content over. And we've also got a Veeam backup file, so I've put that in there for a good reason. It's a .vbk, and yeah, fair enough, it's a backup of a particular subset of data that we allocate. But the important thing here is that we are somewhat a victim of our own success. Okay, it's no good storing backup data on your live environment. You will find that ransomware these days specifically looks for file extensions of common backup vendors. So VBK is our full backup file. So if ransomware comes across that, it will normally encrypt it to make sure that the users can't restore from their backup, because if they can, then what's the point in doing a ransomware attack in the first place? Final thing I want to show you just before we run it, if I right click on this share mapping, we can see restore from previous versions is available to us. So I've enabled shadow copy services on this particular box, and we can see that I've got a timestamp that we can roll back to. Those timestamps that are built into Windows using shadow copy services are local to that particular system. So they're very good, they're very quick to restore data from, but because they're local, not just from ransomware, if that system was to become unavailable, you not only lose all the data, but you lose the backup data as well. So shadow copy services are great, but they do have their pitfalls, so just to be aware of that. So when we run the ransomware attack, let's see if that's still available to us. So here's my ransomware deployments. We're going to be running this one here today. Let's dive into that and just have a look at what's in there. So we've got a zip file. Let's just open him up, extract this now. If I extract all to here, yep, here we go. Here's our file. Long string name there. Let's just put a .exe on the end of that. First thing to notice is he's actually been programmed to pick up the same icon, or very similar icon it would look, to Adobe. An Adobe file, maybe an update file. We could even rename this. It wouldn't make any difference to the exploitation. Adobe.install, or maybe Adobe _updater. Okay, so it looks relatively genuine now. You know, you could see that maybe on a USB stick or maybe on a directory. Maybe it would be emailed through to you. So we've heard in the news about ransomware being low tech. Okay, it's not anything sophisticated when you talk about the mechanics of it. The actual broadcasting is maybe the most taxing thing for them, but the actual software designed and how it ticks is a very low tech. Joe Public could run this. So let's not wait about anymore. Let's dive in and actually see what happens if I run this particular exploitation. You can see my system's egg timering now, so it's actually run. It's far too late to do anything now. The files are still there, they still look healthy. Let's flick up Task Manager and actually have a look at what's going on under the hood. So if we go to performance, we can see we've had a recent spike there, performance hit. That's probably where I ran the ransomware attack, because ransomware is going to go and encrypt all of the files within that particular system. It's not just the things that are on the desktop, bear in mind. Anything that has an extension that the ransomware attack has been designed to corrupt or to encrypt, it will go and do it. So that could be on all those drives that I showed you before. So that's why the CPU is going through a certain amount of load right now, just going through all of those directories and finding those particular areas. And we can see the CPU's chugging along nicely. It's probably going higher than what it normally would, 34%, 50%, 56%. So it's cranking up quite heavily. It's using quite a lot of CPU to run the ransomware attack in the background. You can see that the CPU and the memory is being utilized quite heavily. So let's move that out of the way. We can actually see now that the ransomware has already started to take place. These files have already become encrypted. If you've been a victim of ransomware in the past, you'll know that you've been in this particular point. You may not have seen the particular steps that happen when you run the ransomware attack, which is half the reason why I'm running this demonstration. But you would have woken up in the morning, logged into your systems, and you maybe have seen a load of files like this that were where your previous good files used to be, and you're like, well, what's going on? So what's happened here? Okay, hasn't actually finished yet. Let's just give it a bit more time to actually figure out what's going on. You can see the CPU is still going under a significant amount of load there. You can see it's really churning as it's going through my file system and just encrypting all of that data that it can find. Okay, so let's just give it a few more seconds to finish off doing what he needs to do. He's got the stage at the moment. And you can see he's coming to the crescendo now. He's done a couple of things there. Okay, so he's opening up this web page. I'm just going to move the web page out of the way. The one thing I do want to show you first and foremost is the directory where the exploitation was published to. Okay, where I unpacked it from that zip file. It's actually gone. Okay, so it's actually deleted itself. They've taken the effort to write the code so that they change the icon to an Adobe icon, and they also delete the file once it's been written. Why is that? Well, it stops you from then uploading that back to your AV vendor. Maybe you want to be a charitable person and upload that to the community and say, look, this is the exploitation, it's fresh, here's the problem. Well, listen, you can't. You know, it's too late now. It's removed any evidence of it ever existing on that system. It's probably fair to say the system was actually cleaner now than what it was before, because it's removed that particular threat. Okay, but it has done the damage. It's encrypted our files. It's given us this web page, and it's telling us some very clear instructions. It wants us to go and download the Tor project browser. So let's just click on that. I've still got an internet connection that I've secured down just to this machine. Nothing wrong with the Tor browser. It's designed to understand and interpret onion links. So they want to use that browser to transmit and communicate with you, because fundamentally they need to publish some sort of address to you, some sort of mechanism to share their mechanism of payment to you. Normally that's done via some sort of virtual currency. We won't know until we get there. So let's let the Tor browser run. And also, if I could just click on this link in the background. Yep, so once we've downloaded the Tor project, it wants us to blah blah blah. After successful installation, type in this address into the address bar. So let's just copy that, because I'm not going to type it, I'm far too lazy. Let's copy that, and when Tor is loaded up, we want to put that address into the Tor URL browser. Tor's finished installing, but they've been nice enough to give us a link to Tor. I like that. You know, they've gone their extra mile to say, look, we really want to get your money. Click on this link, download this nice browser. Here's a nice desktop background that we've put on your machine, so you certainly know you've been infected. And here is the Tor browser now. Only took a few moments to get hold of that, so nothing's arduous here. They're making it very easy for us. They want their money, so they're making the steps for us very, very convenient. Egg timer going again. We're just churning that CPU over, and here we have our browser. So let's throw that address in, the onion link. It's whirring away while it finds the location. Sometimes you find that ISPs have locked down the actual page if they're storing it on some sort of reputable board. We're lucky in this case, the demonstration, that that's not the case. So you can see they've got a drop down list here on their web page. They've got different languages, so they've gone to the effort of that. They've got some nice cascading style sheets going on, so they've made the page look, you know, it's relatively aesthetic. It doesn't look very nasty. All these different nice methods to pay. If you don't know how to go about getting a Bitcoin wallet, you can click on one of these links. So, you know, they've been really good to us. They've let us know exactly where they need to go. Here's your unique ID, and we want you to send, here we go, there's the money. There's the money shot. Section 4, send 1 Bitcoin to this particular address. So they've got you now. They've done what they needed to do. They've infected your file system, and they've given you the URL. You've hit the home page. And really now it's just an anonymous transaction of some virtual currency into their Bitcoin wallet, and they will release the, or so you would like to think, release the decryption codes over to you to get your files back. Okay, but we don't want to do that. We want to go and recover from a backup, and I work for Veeam Software, so should have the tools in my kit bag to do that. Let's close that off. This is our box. Let's load up VMware. No, I lie. Actually, let's go and load up our Veeam server. And here's my Veeam server. If you haven't seen our interface before, it's very easy to use. You can see you've got these panels here on the left, and I'm going to go and run a let's go and run a restore instant VM recovery. Click on that button at the top. It's going to ask me for my restore points from all the different points that I've got within that particular system. Okay, I need to select the correct virtual machine, which I didn't do straight away there. So if I do this, I go instant VM recovery. This is the process I spoke to you about at the beginning, where I want to get a workload on as soon as possible. Here's my restore points, all the different points in time that I have a valid backup from. I'm going to select the most recent one. What do you want to do? Do you want to restore to the original location? So we're going to basically overwrite that previous VM, or do we want to restore to a new location with different settings? Let's do that because it's a demonstration, so it'll be nice to show you how that works. And the main thing I probably want to change here is I probably want to give it a new name, so I can distinguish it between it and the if I can spell restore, the compromised system. And let's just put it into the root of the resource pool and go next. I don't want to redirect my virtual disks. Just put a few letters in there to suggest it's a restore. Do I want to connect the VM network automatically? Do I want to power on the VM automatically? I'll tell you what, yes I will. I'll tick both of those because I want to get it on, and it's going to come up with a nice little warning here saying make sure the original server is powered off, so we can do that in just a moment. So VM recovery is still in process. We've just kicked that off. Let's go and launch up VMware, and we'll kill the original VM, which is this guy here. I'm just going to put him into a suspended state, so that's the compromised VM. And in the background now, what's happening is Veeam is taking care of restoring that virtual machine to us in an instant VM recovery scenario. Okay, so what it's doing, we're not rehydrating data, we're not moving vast amounts of data around. All we're doing is connecting VMware to the backup infrastructure. We're literally booting that virtual machine. Doesn't have to be one, it could be a number of virtual machines from the backup tin, essentially the backup disks, and we're presenting that back to the network. Should happen within just a couple of minutes. So we can see the machine has already gone online, so we can see that there. The status is probably saying that he is powered on. He is. Let's go and actually look at the console of him and see what's actually happening. Here he is. Let's click on him, and you can see already within Windows he's actually already come up with the splash screen. So let's go and check him out and actually see if we can log in and see what's actually happened. Here he is. Let's go and connect to him. And you can see Windows is booting. This is not Veeam now. We're just waiting for Windows to chug along. You know, we've presented that VM within probably less than 2 minutes, maybe just 1 minute to get that back online. It took me longer to go through the wizard, and it took longer for Windows to boot than it took for Veeam to present that data back to the environment. and it's worked. You know, we have our data. So here's our Excel spreadsheets. Here's our picture. So we can click on that again and actually have a look at what's going on there and see that that's all good and healthy. So you know, the machine has been recovered. You know, we know what the repercussions of the ransomware were. We could see these were all encrypted files. We couldn't open them and access them. They've been totally corrupted. But I tell you what's interesting. I actually have the Veeam agent running on this particular machine, and let's just go and take a look at that. We haven't used the agent to recover from, but it's worthwhile talking about, because in the agent we can use this for virtual machines or physical workloads or any particular workload, as long as it's Windows or Linux. And we can actually do quite a few unique things here, one of which is, I just want to share with you, is the ability to repoint where our backups land at. Now we can see in that scenario we compromised a lot of the data. We compromised the data living on those file shares, we compromised the data living on the desktop. But within our agents we have the same functionality. We can store data locally into local storage directories or maybe a shared folder. These are great, very quick, very efficient, but they do have the downside that they're going to be susceptible being affected by ransomware as well, because they're on that same fabric as your production environment. So if you have a ransomware attack in your business, it's going to proliferate through the network, traverse over to your backup directory and affect those files as well. Equally so, we have a Veeam backup repository. So this is where we have our containers, essentially our disks where we like to store data down onto. We can do a few unique things in there to make sure that's isolated from the environment, create a backup copy job, and that protects from essentially ransomware attacks. But the interesting one I want to draw your attention to here is the Veeam Cloud Connect repository. So this is actually where ultimately we can take our data, whether that be a virtual machine, a physical workload, and push that directly into what we call a Veeam Cloud Connect platform. And that's going to live in a service provider environment, either as a backup as a service or DR as a service entity. So we could have used that. That would give us a very unique disconnect from our production environment to our backup environment. It's going to live in the cloud on a service provider's platform in an environment where you know and trust, and you know that organization and all the good things they're doing for you as a business. Okay, not really ideal for this scenario, because obviously restoring data from that cloud platform, we'd have to traverse the data over the internet, so would be a little bit longer. But again, ultimately your data is in a cloud platform that's isolated from your environment, so gives you a very unique and safe way of recovering data from. If we go back to Veeam very quickly, let's actually decide that we're going to stop publishing that machine, because we've decided we're happy with it, we've recovered our data, we no longer need that virtual machine. So we can either migrate that virtual machine back into our environment. If I just click up here, we can migrate that production, so that will basically make it a live VM, and therefore all the users will be completely ignorant that that's going on in the background. They'll just continue to work on that live data. Or actually, if we've taken the data out manually, we could just stop publishing it. And what that's going to do, it's just going to reverse process all of that good stuff that we did, publishing that to VMware. So there's no need for us to do that at the VMware level. Veeam takes care of that for you. It disconnects the backup architecture from your hypervisor, and you can see it was very quick to clean that operation up as well. One thing we didn't do, we didn't check out properly the actual status of the files. So let's go and just reconnect to the infected machine, the one that actually had the problem. I'll just probably need to go and resume it because I paused it. This is the one that's actually has the problem with it. Let's just go and see what he looks like, because I showed you at the beginning the volume shadow copy directory and also the Veeam backup file. Let's go and actually have a good look at what actually happened to that encrypted data once the exploitation had run on that particular machine. So again, it's just having to boot up off VMware now. Standard technology, waiting for it. But this machine's been compromised. You know, there's no way that this is in a good state. The data in there is not in a healthy situation. So we're just waiting for Windows to do its thing. Yep, we're back to here. So this is the corrupted machine. We're doing a bit of a yo-yo here, going back and forward, but no problems. You get the point of this. If we launch up the Windows Explorer directory, let's just have a quick look at this. you saw before that I had volume shadow copy or shadow copy services enabled. If I go to restore from previous versions, we had one restore point in there before. So let's just give that a whirl right now. We can see. So in Windows, there's a shadow copy cache where Windows will organically just check all that. If it's enabled, will just check all the changes without your system. So it really is a unique feature to use. But you can see the ransomware has run on that system. It's affected all the files that are on the desktop. So we can't open these because Windows doesn't know how to interpret them. We either need to restore from backup or get the decryption keys. Okay, there's no way we're going to get that. But it's also gone and affected our actual VSS. So again, no good to us. If that system was to fail as well, we'd need an off-site backup or a backup move to another location. So we need to mature our understanding of backup in order to protect against these circumstances that prevail to us in the modern data center these days. So that's it really. I wanted to cover off some of the high-level points around how the ransomware attack actually runs, some of the mechanics behind the scenes, and more importantly, how you can recover from that using instant VM recovery with Veeam. I hope that's been helpful. Any more questions, please don't hesitate to contact one of our systems engineers. They'll be more than happy to give you some guidance.